Hello there. In this class we are going to be discussing our first theorem, which is x plus x equals x. So we are going to prove this theorem by using the rules that we have already discussed. These are the postulates or the axioms that we have discussed, which were presented by Huntington. So this first theorem can be proved by all of these laws. We will keep using them and mentioning them throughout the proof. So if I want to find out the proof of this law, I can either go from the left hand side or I can either go from the right hand side. I think I should go from the left hand side. You can also go from the right hand side, that doesn't really matter, so you can prove from both sides, but let's say I'm picking the left hand side. So left hand side is x plus x. Now I need to do some modification to x plus x, which I can do by replacing these x with something else. So I should go to this table that I have created here. Let's see which expression can I replace my x with. So I have two options here. I have one option is x plus 0, one option is x plus 1. Let's go with this one. That doesn't matter. Again, you can try this one too and you can see the outcomes. You can also try this one and you can see the outcomes. I have already done this frequently, so I have seen that this one is pretty much efficient and less time consuming from the other one. So I'm picking this one. So I'm going to replace my x with this one, x dot x. So one x is on its own place, plus with on the instead of the second x I'm going to replace it with x dot 1, which is I have done by identity law. So I can mention it here that I have made this replacement using identity law. Now I've got something like this right now, x plus x dot 1. Now what can I do again? I can replace this x again, but I don't want to do that again, so I can replace this 1 right now. Let's see in the table that is there any replacement for 1. Yeah, if I see right here, 1 can be replaced with x plus x. So I can write something like this here, x plus x is on its place, dot, instead of 1 I replaced it with x plus x bar. So again I did this from the or by the inverse law. So this was from the inverse law, and now I have something like this. So if you see this one, you can easily go to the distributive laws row. You can see the same outline here too. So I can replace it with this one, so I can do something like this, x plus x dot x bar. Now I did this by the distributive law. It's important to mention this in front of this, it's the part of the proof. So now I have got something like this. Again, let's see for more replacements. So I have got x dot x bar here. If I again go for it here, if I see here, I have got x dot x bar, which I can replace with 0. So that's good for me. X plus x bar can be replaced with 0. So I have done this by the inverse law again, by making a replacement using the inverse law. Now I have got x plus 0. Let's see if there is a replacement for x plus 0. I think there is right here. If I see x plus 0, I can replace it with x. So I can simply, instead of all this, I can write x here. So let's see again how did I found out all these steps. First of all, I replaced x, and then I replaced 1 with this one, and then I replaced this whole expression with this one here, with this one, this whole expression. After that I replaced this one with 0, and after that I replaced all of this with this x, and this is my final answer. Now as you can see, it was x here, so I have made it to x. So it means that I have successfully proved it, that x plus x is always equal to, it will always be equal to x. Now as you remember, we have seen that all of these theorems and laws come in pair. So if I see the the second part of theorem, this theorem, it will say something like this, x dot x equal to x. But you can also prove this manually, but you don't need to prove it. Why? Because if you see the relation between x plus x equal to x and x dot x equal to x, you will find out that this is the dual of this one. If you remember the duality principle, if you don't remember the duality principle, I think a couple of videos before I have discussed the duality principle, where I have said that if we interchange this operator to this one, the statement will always be valid. there will be no problem in this statement. So you can simply write here that proved by duality principle, because this is a dual of the other expression that I have already proved, so I don't need to prove this one. This one automatically satisfies if it's dual also satisfies. So this was the first theorem that you can prove. This is always not, you can also follow some different steps to prove it. You can also follow the other hand side of the equation to prove it, but this is the most easiest one that I have picked for you guys. So this is how you prove the first theorem. In the next class we are going to be proving our second theorem. So see you then, bye.